Section 5.5, example 6, finding the zeros of a polynomial function with complex zeros. So find the zeros of this function. Ooh, this looks like fun. Okay. Let's start off with checking to see if we have a representative for each of the terms. X to the power 3, to the power 2, to the power 1, and 0. Okay. We got that, so we're good there. Now let's list all possible zeros. So possible zeros, plus or minus, and they'll be in the form of factors of 3 divided by factors of 3. So we have factors of 3 are 1 and 3, and factors of 3 are, again, 1 and 3. So possible factors are going to be 1 divided by 1, which is 1, 3 divided by 1, which is 3, then 1 divided by 3, which is 1/3, 3 divided by 3, which is 1, plus or minus. So we have 1, -1, 3, -3, 1/3, and -1/3. So of course, we're going to try the easy ones first. And we do have a representative for each of the terms, so we could jump into our synthetic division. Let's start off with the easy one. 1. We have 3, 9, 1, 3. Bring the 3 down. 1 times 3 is 3, plus 9 is 12. 1 times 12 is 12, plus 1 is 13. 1 times 13 is 13, plus 3 is 16. So not a 0. Let's try the next number, -1. 3, 9, 1, 3. Bring this down. -1 times 3 is -3. 9 minus 3 is 6. 1 times 6 is -6. 1 minus 6 is -5. -1 times -5 is a +5, plus 3 is 8. So those didn't work. Let's try +3. We have 3, 9, 1, and 3. 3 times 3 is 9. 18. 3 times 18, that's 4. 54. That's 55. And we could technically stop here because we know that that's not going to end up being 0. Let's try -3. -3 for 3, 9, 1, and 3. Bring this 3 down. -3 times 3 is -9. That's 0, 0, 1. -3. I think we finally found our winner. Okay, so we have f of x originally was 3x cubed plus 9x squared plus x plus 3. We factored out x equals -3. So we factored out an x plus 3. And we're left with 3x squared plus 1. Doesn't look pretty, but at least we have something that we could factor. So it's not that we could factor it, but we could actually just look for the other 2 zeros, or we could factor it. So what we're looking at now is our 3x squared plus 1 equals 0. And actually we could just solve for x. And solve for x again. -1/3. And from here, we take the square root of both sides. Yeah, these aren't going to be rational, but we could still factor. So x is equal to plus or minus the square root of -1 over the square root of 3. Let's rationalize this. So the square root of 3 over 3i. So there's that. Those are our two zeros. So what we have is x is equal to root 3 over 3i and also negative root 3 over 3i. And when we plug it back into our function, we have our x plus 3. That's what we originally had up here. That's what we originally had right here. And what we just found were these two zeros. So x minus root 3 over 3i, and also x minus negative root 3 over 3i. But we could just simplify that to plus root 3 over 3i. And although they're not rational roots, they're still like the roots and the zeros of this function. And look, I didn't even plan it out. It's a little heart right here because I love you guys. All right. If you have any questions, please feel free to ask. Otherwise, bye.